Right, this is going to be one of my faster videos, hopefully. Right, we'll be doing about the carbon cycle, okay? And we'll be doing like carbon cycle basics, and we're going to look at methane as well and the implication of methane, because methane is CH4, it contains carbon, it's naturally occurring, and therefore we need to know about it. So, at stages you'll have to like pause this video, get your book open, and make a diagram of the carbon cycle, because we're going to add detail to it. So I know a couple of you in the feedback asked to, can you go back over things? It's like the nature of this topic. Again, there's nothing new. Well, there's bits of new now actually, but it means that we're all going to go back over things. So this is our carbon cycle plus. We're adding things onto it. So far, we've just looked at that bit of the carbon cycle. Okay, the thing that I've circled in blue. Ideally, you've got some coloured pens. We're going to make a key. So pop a title down, carbon cycle plus, give it the date, and then make a key. Get 4 different colours or dotted lines and things. Again, you can pause it and get the equipment. So I'm just going to carry on, assuming that you've got things and you're ready. But the beauty of technology, you can always go back. It's not like a one-hit wonder. Right. So first of all, photosynthesis. Crucially, there's only one arrow going into the the living part of the ecosystem. So all of this is like on the ground or in the ground really, and all of these are in the atmosphere. I put 2 CO2s simply because it avoids me crossing lines over. I'm a bit pernickety about that. So yeah, photosynthesis, carbon dioxide is used by plants and algae in photosynthesis. Glucose is made. Glucose can then be joined into starch, all that page Mr. Council stuff. Okay, so hopefully we're okay with that. There's only going to be one green arrow on this diagram. Okay, from then we're going to look at respiration. Well, everything living carries out respiration. It's the R of Mrs. Gren. So therefore, well, are plants alive? I'll give you a minute. Yes, they are. So they also do respiration, and CO2 goes back to the atmosphere. Animals, obviously alive, they carry out respiration and release CO2 back into the atmosphere. Okay, there's one other living thing on this diagram that releases CO2 into the atmosphere due to respiration. And well, I've got plant and algae, they die and become detritus. Well, detritus is just dead stuff. Biofuel is just a fuel, that's not alive. Peat is like a rich soil type thing that we're going to learn about. Fossil fuels aren't alive. Decomposers, they're the bacteria and fungi, they're alive. Therefore, I need an arrow from there going back to CO2 in the atmosphere. Okay, so that's kind of what we did at the start with our carbon cycle light, and we should be able to describe how CO2 can move into a plant, into detritus, and you had a question on this anyway that I marked and gave you feedback on via decomposers back into the atmosphere. I never talk about carbon moving. We always talk about carbon dioxide moves into the plant through the stomata. It's converted into the carbon compound glucose that's fed on by the animal, okay, etc., etc. Next one, anaerobic decay. Well, anaerobic means without oxygen. So if there's less oxygen, then the decomposers, crucial bit says decay, can feed on detritus, and some of them, called methanogenic bacteria, produce methane. I do this. Yeah, in my large intestine, food I can't digest ends up in the large intestine. There's methanogenic bacteria in there that make methane, much to everyone's amusement. Everyone loves the methane that I produce. Okay, cows make loads of methane. They burp methane. They belch it. Yeah, they make so much. There's a condition in cows called methane bloat, where they make so much methane it gets kind of trapped in their complex digestive system, and they just blow up. Not boom blow up. They just inflate, and the vet comes along with a big like a scaffolding pipe. So it's a big metal pipe, puts it up its anus, finds the blockage, and then it vents the methane out. So it always amazes me that our brightest and best want to be vets, and they end up either like cleaning dogs' anal glands or degassing cows. But must be very fulfilling. Anyway, yeah, so that's where we're going to focus on today, methane, because it's a really important gas. Yeah, that it's a gas that we burn. Methane comes out of our gas taps. It's what powers up my gas boiler. However, in the atmosphere, it's a really potent greenhouse gas, and that's where we're going to kind of go from methane. How we can kind of use methane in a good way, but what's the bad side to methane being in the atmosphere? Yeah, how can we minimise this happening? Because if decomposers are letting methane get into the atmosphere, then again it has a lot more warming effect than carbon dioxide does. It's better to burn it than to release methane. Okay, speaking of burning, we're going to put some combustion onto this diagram as well. So detritus can also be classed as a biofuel. You can chop a tree down, that's now detritus, and therefore when we burn that, it gives us CO2. We grow palm oil. Again, technically, when you pick it, it's now detritus. So I've got ahead of myself there. Sorry. Yeah, there's one more methane one. Yeah, and it's kind of a bit of a cheat. That the animals produce methane, but it's really the bacteria inside the animals that produce methane. Yeah. Anyway, back to combustion. Yeah, so biofuels can be burnt to produce CO2. We're going to see that peat can, well, you can burn it and release CO2, but also if it decomposes, it can release CO2 as well. So we're going to learn about the exciting world of peat. It is actually quite exciting. And also we know that when we burn fossil fuels, that also releases carbon dioxide. So there's like a burning side to the carbon cycle. Admittedly, in biology exams, we tend to focus in this area. However, there are marks for if it says how is carbon cycled in the carbon cycle. You can talk about fossil fuels and biofuels and things. So we're going to be meeting biofuels a bit. In fact, we're going to be making a biofuel in our next bit of this lesson, and also we're going to look at peat. Okay, just before I move on, just while I've got you, I'm just going to show you a bit about global warming, which I think you do in physics. I could be wrong, but you'll done it further down school anyway. Here's the sun, in comes UV radiation. Okay, that hits the ground, that warms up the ground, so it's absorbed, and then it emits infrared radiation. And if we had no gases in our atmosphere, the energy coming in would just equal the energy being radiated out into space. Yeah, the moon's barely got any atmosphere. It's like a couple of millimeters thick is the atmosphere. And when the moon's in sunlight, it gets incredibly hot. As soon as it turns around, it radiates all that heat back into space again. It goes incredibly cold. Okay, whereas we have an atmosphere that traps some of the heat. So the gases in the atmosphere warm up, they absorb the infrared radiation, and CO2 does a lot of that. Water vapor does loads of that as well. So that's like a natural gas in the atmosphere that keeps our planet warm. However, methane is a very good gas at holding heat. So if there's methane in the atmosphere, or if there's CO2 in the atmosphere, then that can trap more heat. And the more CO2 you have and the more methane you have, the hotter and hotter and hotter it can get. And it's something that we're worried about now because we're releasing lots of CO2 due to burning fossil fuels. That's have a warming effect on the atmosphere, therefore the planet's warming, and that has a whole set of ecological effects that we go through. There is no doubt that the planet is getting warmer. Some people think it can be explained by natural processes. Some people think no, it's man-made, humans. It's us burning fossil fuels. So there's some debate about that, but there is no debate that the planet is getting warmer. We've got data on that. So you're also going to be doing a little bit of work on global warming, and it's really linked to methane and carbon dioxide. So I'm going to leave it there, and there'll be another task for you to have a go at if you just read on to the next task. Okay, goodbye.